Welcome to solverfy.
This is the answer to Chapter 15, problem number 43 from the Smith Organic Chemistry textbook. And this problem asks us three things. So we're given molecule Y, and we're asked which products, excluding stereoisomers, are formed when Y is heated with chlorine gas. What products, excluding stereoisomers, are formed when Y is heated with bromine gas? And what steps are needed to convert Y to the alkene Z, which is also given to us there under the wording of the problem. Okay, and so for A, when we heat Y with chlorine gas, this is a radical chlorination, and radical chlorinations are not selective, unfortunately. And so we're going to get chlorination of every possible position in this molecule. And so there's one. Here is a second possible position. Oops, I forgot a methyl group. There we go. So here is a third possible position. Here is the fourth possibility. This is the fifth product that we'll get, chlorination down here. Okay, and then lastly, we will get a sixth chlorination product that is going to be right there. Okay, so those six products, we will get a mixture of all six of them. Okay, so then for B, we're asked about the same thing, but with bromine gas or liquid bromine. It's going to depend on what temperature it is in your lab. Okay, and so if instead we use elemental bromine in heat, what we get is monobromination only at the most easily abstracted hydrogen, which is going to be the only hydrogen on a tertiary carbon in this molecule. So we get this single product, and so that gives you a pretty good idea of how much more useful bromination is than chlorination in many cases. So then for C, I think that we can fit this all onto this one page. For C, we're asked to convert from our starting material Y to this alkene Z. And so in order to do this, we're going to start with a radical bromination. And obviously we would select the bromination here because we only want a single product. And if we were to use the chlorine instead, we would get the six products that I drew above. And so we get our bromination product here. And now we can treat this with some potassium terpetoxide. And that is going to eliminate the halogen and a hydrogen. And so we get our target alkene. Okay, and so that's molecule Z. And so that's the answer to this problem. So remember, chlorine is not selective at all, or I suppose I should say radical chlorination is not selective at all, and we'll get reaction at every possible hydrogen in the molecule. Radical bromination is selective, and so we will get a single product here, the product of only the reaction at the most susceptible hydrogen, which is the hydrogen on the tertiary carbon. And then to get to alkene Z, we need to do a bromination followed by treatment with potassium terbutoxide to eliminate our halogen and get us to the alkene. And that's the answer to chapter 15, problem number